So one of the tricks with this one is that after we use the quotient rule, there is an e to the x present in every single term in both the top and the bottom. And so yes, we do want to go ahead and reduce those, cancel those out. So we cancel out the e's and e to the x's out of both top and bottom, and you end up with that as a more simplified answer. Please note, I hope that you're looking at something like that and thinking, is that something special? Is that a trig identity? It's not, but I want you at least thinking about that because sometimes they will be. Now, as you're taking a look at this problem, of course, it looks different than the ones we've previously done. Because we just have a table with a bunch of numbers, but we can still use the same rules. And really what this side is going to try to do is it's going to try to reinforce the idea that these rules all apply there. So, first of all, which rule will we need to use in this case? Well, we're trying to find r prime here, right? R equals f times g. Well, if we're multiplying, that means the product rule. Hence, multiply product, right? So we need to use the product rule, which means that in order to figure out what r prime is, I'm going to have to do f times g prime plus f prime times g.
Why?
That's product rule.
Yeah, but
And for some of you, just seeing it this way is kind of a mind bend. It's the same thing as what we've done when we've had like e to the x times x squared or something like that, where we're doing original times derivative plus derivative times original. Same idea. Just here we can actually figure out what these values are. So if I want to figure out then what r prime of 2 is, then I'm going to figure out what f of 2 is. Okay, so I can look up in my table. F of 2 must be right here. And so that's going to be negative 2 times g prime of 2.
why do you know it's negative? Because this is the table.
So
We're just saying.
go to your table.
I got you. Just look at
G
the table.
prime of 2 would be right here. That would be the negative 1. All right, so then that's going to be negative 1 in there. Plus, now we need f prime. So f prime of 2. All right, so that's f prime. Go down to 2. And notice that gives us 5. So that'll be 5. And then we need g of 2. So we go to g of x. You go down to 2. That's 0. And so it ends up like that. So to get our final answer, then we actually just go ahead and do that math. So r prime of 2 then would equal 2. And that is it. That's our final answer. It's just a nice way to practice product rules, see how it can be used in other contexts, and sometimes we do have just the raw data like this, and we have to be able to utilize it. We can do the same thing with quotient rule and all the other rules we end up seeing. Now, this is the same table, so you don't need to recopy the table, but go ahead and practice what we just did. Please find r prime of 0. So in this case, you notice that it's actually defined as being f divided by g. So we have to use quotient rule. And so go to quotient rule and then plug in from your table from here. So you'll notice here that p of x is defined as f times g. So if I want to find p prime of 2, that means product rule. So really this is the same thing as what we just did, where we're going to have to use product rule. So for p prime, we'll do f g prime plus f prime g. It's just that to get each of these values, we're actually going to have to go to the table and actually find out what they are from our graph, rather. It's the same way as when we did it from the table. It's just that now we got to look up the values on the graph itself. So, for this one p prime of 2, we first need f of 2. F, you'll notice, is the purple graph up here. And we're looking to see what the value is when x is 2. That's up at 3, yeah. And so it's going to be 3. And now we need g prime.
Is it 1?
Well, g prime of 2, well, we're actually going to have to do a little bit of work there.
Oh.
Because that means we need to know, at this point, what's the slope?
1/2. 1/2.
Yep, it's 1/2. Good.
So prime is
1/2.
Because derivative, of course, means slope of the tangent line.
Oh, lordy.
All right, plus.
That would be 0.
Now we need f prime of 2. So that means the derivative at this point, or in other words, the slope at that point.
0.
Which, yes, is 0. Good. So that's going to be 0. And then it doesn't really matter what the next one is since it's being multiplied by 0. But we can go ahead and get that. It ends up being g of 2, which is 2.
Wait, how come the derivative
Right there.
Does it pass the vertical line?
Because the slope.
So as our final answer, we get 3/2 or 1.5 or 1.5, whichever way you choose to give it. Having done that, go ahead and now please apply the same ideas to finding q prime of 7, where q, notice, is defined as f over g. So when approaching this problem, we have to start by saying that tangent can be rewritten as something we can work with, because of course tangent we don't know yet. So we turn it into sine over cosine. Now you can go ahead and use quotient rule with the sine x over cosine of x. So once you've gotten to this point, we can clean up. So now f prime of x can equal, well, cosine times cosine is cosine squared. So I can rewrite that as cosine squared x. And then minus a negative sine, okay, so that's going to be plus sine squared of x over cosine squared of x. Okay, so we're making good progress here. Can I cancel out those cosine squareds?
Because it's addition.
Nope, because there's not a cosine squared over here.
Stop ruining this surprise.
But the part that we can simplify here, what's cosine squared plus sine squared equal?
1.
1, yep. So we end up with f prime of x equaling 1 over cosine squared of x, which we can even simplify just a little bit more. Because what does 1 over cosine equal again?
secant.
Secant.
How?
And so it's going to be secant squared of x. This is worth putting into your notes.